Welcome to Tech Gig Webinars, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, Tech Gig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is fifth in the webinar series on business intelligence, giving insights into big data and the future of data warehouses. We are delighted to have Mr. Hemant Kulkarni with us today. Mr. Hemant is Senior Solutions Architect at Capgemini. He has over 22 years of enormous experience in IT and extensive experience in business intelligence, data warehouse, and master data management. Hemant has high in-depth experience of implementing large data warehouses end-to-end. His current research area is big data and is also focusing on cloud business intelligence as well as mobile business intelligence. Gentlemen, this presentation will continue for next 1 hour and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Hemant.
Hello. Hello. Keshav, am I audible?
Yeah, Mr. Kulkarni, you can go ahead now. We can see your presentation also.
Okay, I can start, right? Okay. So, good afternoon, everybody. My name is Hemant, and I'm going to talk about big data and the future of the data warehouses. Let me briefly go through the agenda, what we are going to cover. There are multiple terminologies currently floating in, and it's essential to understand before we jump into understanding the Hadoop as such. Terminologies like big data, Hadoop, Nosql data, touch upon those topics and try to understand what exactly the Hadoop framework, the architecture part of it, what does it cover. Then we'll get into Hadoop and data warehouses. Are these really two technologies competing each other or complementing each other? What's going to be the future of data warehouses after the Hadoop has come into the picture. And then we'll see briefly on the relevance of Hadoop, where Hadoop would get used, what is the relevance with respect to analytics, with respect to cloud and all that. So to start with, let me talk about the current data challenges the organizations are currently facing before we jump into the big data part of it. The multiple challenges with respect to the data the organization facing are mainly due to the mergers and acquisitions. Too much consolidation happening, two different applications getting merged into and increasing the data volume. At the same time, new technology adoptions, from the ERP to CRM to data warehouses, web applications, and analytics, all those technology adoption by the organization has certainly increased the data volumes. And the third most important aspect is the need to access the unstructured data. And a lot of unstructured data, as we all know, lying in the form of flat files, Excels, and documents. How bring a sense out of those documents. And on top of that, now what has come into picture is the internet data challenges. You can see the data volumes which are generated. There are more than 2 billion internet users using internet on regular basis. Facebook, if you see, this around 10 terabyte of data every day which is getting loaded. Around 150 billion messages get stored into Facebook on a monthly basis. You see blogs, 152 million blogs exist as of now on the internet. People read those blogs, there are messages, there are comments done on that, and if you see from the Twitter perspective, it's 8 terabyte of data every day. Now, why this data has become more essential or important for the organizations? Certainly because of the social media analytics. Organizations certainly want to understand the customer sentiments, customer segmentation, their preferences, and how do they reduce the churn. That's the key thing which organizations want to do using internet data. With this multiple data challenges, can really an RDBMS cope up with that sort of a data load? Maybe, there may be. Technically, it's quite possible. If you see the eBay data warehouse, eBay data warehouse is somewhere around 6.7 petabyte, which is running on to earlier in Greenplum, now on the Teradata. So you can have those huge data warehouses the same way the Walmart has the huge data warehouses, but there is a cost associated with it and very, very expensive. It's all resource centric. We'll see soon the difference between the way RDBMS works versus Hadoop, but it's all resource centric processing is a centralized processing which is happening into the RDBMS. So new data means you need to acquire additional hardware, you need to put additional database servers, and that's certainly going to be very expensive as the data volume grows, as mentioned above, in the form of petabytes maybe. Also, the scaling is a problem. Even if you are going for the data warehousing appliances, 100 nodes, 200 nodes, as you keep on adding the nodes, there is a limitations even if you go for the appliances sort of a thing. So what is the way out? There's a new stream of data computing will resolve these challenges, and that's nothing but an Hadoop. So what we are saying is all those different data challenges which organization faces from the internal as well as external perspective, there is a solution to handle that sort of a big data. Let us move and try to understand what exactly does it mean now a big data is. Okay, big data is certainly associated to the volumes. Yeah, the large number of data sets is certainly one of the aspects of a big data is volume. Data in terabytes, petabytes, or even maybe in hexabytes will comprise a big data set. But the volume itself would be any data set, will it be called big data only because of volume? I feel no, because there are some other aspects of the big data as well. The important another aspect is velocity. The data is changing. The enormous data coming in, certainly the old data becomes stale very soon. So there is a need to analyze the current data which is coming in. So to analyze the fresh data, to take care of the velocity of a data, you need to have right systems in a place. So another aspect of the big data is not just a volume, but big data is also very high moving, fast moving, and it has got a very high velocity as well. The third important aspect is variety. There are a variety of data sources now coming into the picture. We are talking about the internet data, but there is a huge amount of data which is lying into the instruments. The sensors, RFIDs, smart meters. Those are all, feeding the data in the form of streams. Now, is it a new thing? No, really. Earlier also the sensors were there, RFIDs were, they were feeding the data. They are feeding the data. But with the availability of the different technology platform, it has become very important to understand and analyze what the sensors data will also provide me, what intelligence the sensors data will provide me. External data, blogs, social medias, web logs, even firewall logs, that all external data is also very important to understand when it comes to the web analytics sort of an applications. And so basically we are talking about an unstructured data, semi-structured data, and structured data coming from the external sources that all makes a data element or a data set as a big. So volume, variety, and velocity, and the third important aspects associated with it, the complexity. So the data elements not only are varied in nature, but they are complex in nature. The videos or the audios which gets recorded at the BPO level or audios which gets recorded at on a flight, basically. So just to give an example with respect to big data, the Boeing jet, basically, when the Boeing jet flight is a twin engine flight, when it is in air, the generates somewhere around 10 terabytes of data in 30 minutes. Now that data is all with respect to the sensors. There are a lot of sensors in an aircraft. They all keep on sending the data in the streams. There are the flight data recorders. There are the audio recorders, which keeps on recording the audio of pilots when they are talking to the control panels. So there's a huge amount of data, 10 terabyte of data per 30 minutes. Now, if if you still consider, though not realistic, that a single flight may fly only for 30 minutes, on any given day, only in US, there are more than 28,000 plus flights in air on any given day. So even if we calculate the duration of a flight with the assumption that the flight would fly only for 30 minutes, and if we combine that data all together, and for a month itself, it would end up generating around an exabyte of data, not even a petabyte of data. So that's a huge amount of data. And what different data types we are talking about over here? The sensors data, the audio data, and also at the same time the internal systems data, which is going to talk about the passengers information, the flight information, and all that. So that's the variety of data Boeing is going to generate. Now, if they really want to analyze this data, what's going to be the solution for them? Certainly, Hadoop is the solution. So what basically Hadoop is? We'll get into the Hadoop architecture, Hadoop history soon. But here I'm just trying to explain at high level what Hadoop is basically. It's an open source implementation of a MapReduce. So what MapReduce now? MapReduce is a technology which got I will not say really invented. It got discovered. It's an old technology, but it got discovered again at Google, and we'll talk about in detail about MapReduce soon, how MapReduce works, what is the architecture. But in short, if I have to explain, MapReduce is an algorithm which is used to process the distributed data. Duck cutting is a person who was working at that time into the Lucent lab, okay, and once the paper was published in 2004 by Google on MapReduce, he understood the importance of this particular technology, and he decided to use it into Lucent and the Nutch, the search engine on which he was working actually. Basically named after a toy, because many times this curiosity we have, how come so different name Hadoop? It's basically a toy name. This is the framework basically for running applications onto the large cluster. So the data now. We have heard this terminology a lot. It's basically, it says not only SQL database. It's not like getting rid of an SQL, but there are databases nowadays available which can help you to process not only the SQL queries, but it can also access different interfaces. The interfaces may be in the form of a Java, maybe in the form of a MapReduce functions. It accesses the large amount of data. They are basically non-relational databases, columnar databases, and very useful mainly when it comes to processing. I'm not going to the details of the difference between an RDBMS and columnar database, with the assumption that you know the difference. But mainly the columnar databases are pretty fast the way the data is structured in the form of a columns, and they can scale horizontally. When it comes to the size part of it, they can really grow into the petabytes. That's what the basic advantage of the NoSQL databases. So what are those different flavors of NoSQL databases available at this moment? There are a variety of databases. We have XML databases, we have column databases, we have key value databases, the graph databases, and even the recently the popularity which are gaining are the CouchDB and MongoDB, which are basically document databases. The huge documents getting generated maybe on the internet, they can be really stored into these databases, and a MapReduce can really work on these databases to make a sense out of these documents. So what basically, so if I have to tie up these three, it's a very crude way, but just from the understanding purpose, I'm putting this. So big data is basically a concept. We are talking about a huge volume of data which can be deployed using Hadoop framework, and NoSQL databases is actually implementation of an Hadoop framework. So Hadoop is nothing but, as I said, HDFS, Hadoop file system, and a MapReduce algorithm, MapReduce functions. Now so that's the reason it is called as a framework. You need to have some applications, some databases sitting on top of that, which can ease your life. You can do everything whatever you want into the MapReduce, but it's going to be a fairly complex job. So the NoSQL databases can really help you to extract the data from the unstructured data, maybe into semi-structured form or a structured form, and can provide the information or the analysis on top of that. That's all about at high level understanding the big data part of it. I will get into the Hadoop framework, and we'll talk mainly with respect to the MapReduce functions of it. Why I'm calling it as a Google MapReduce? Because it got invented at Google, but basically it's a MapReduce now. It's a part of an open source. Let us try to understand the history part of it, how MapReduce came into the picture at Google itself. It was introduced, as I said, Google published a paper in 2004 regarding MapReduce, and this is a framework to process the large amount of data. Why Google felt like a need for using the MapReduce? The reason for exploration is simple. The number of documents, the internet was growing, and indexing the web, or even the ranking the documents so that those can be displayed in that order to end users, was becoming a very, very tedious activity at Google end. And on top of that, they wanted to work on the trends, the geographical information. Now, to handle, it was not possible to handle with the available infrastructure at their end. Once upon a time, Google was using more than 4,000 plus MySQL implementations, just to take care of this entire data volume. Now, that too was not able to help them, so the engineers basically. Again, the history for this is, there were a lot of Alta Vista engineers who are working. They started really working on this algorithm, and when Alta Vista taken by Compaq, and then later when HP took over the Compaq, on their roadmap, there was not much of a focus on doing R&D on this particular stuff. By virtue of which all these Alta Vista engineers moved to Google, and that knowledge was shared with Google, and the entire team decided to work on the MapReduce, which certainly helped them to improve their the performance, not from the web application perspective, but with respect to their internal commercial applications as well. So just to give you a few statistics, they did an exercise in September 2007. The data which was fed in to the MapReduce jobs was 403 petabytes, and the nodes used to process this load were somewhere around 394. And you will not believe, but this entire job, all the jobs which MapReduce fired on this 403 petabytes got completed into 6.5 minutes. That's the tremendous speed which we are talking about. Just to show you a few previous statistics, I will not go into the details, but if you see how MapReduce have enhanced over a period. If you see in August 2004, the number of jobs fired were 29, and it took them somewhere around more than 10 minutes on 157 nodes. While in 3 years, if you see in 2007, the number of jobs fired were more than 2,000 plus on 394 nodes basically, which contains 403 petabytes of data. So that's the scale at which the MapReduce can really work. Okay. Let me get into the history of Hadoop briefly. We spoke about MapReduce. Now the MapReduce is basically a base for Hadoop. In 2004, Google published a paper on MapReduce algorithm, and duck cutting, as I said, he was the person who was working under the Listen lab. He understands the importance of this framework, and then he started implementing it into the Listen. Okay, he was also later working into Yahoo, so Yahoo decided to adopt this particular framework, and somewhere in 2007, this became an open source and became a part of Apache Foundation. And then there are a lot of contributors and committers started contributing into this framework, and now this is a framework onwards that has been started supporting 128 MB block size as well. So we have master nodes, we have the slave nodes. There are the daemon processes like job tracker and task trackers, which are working on master and slaves respectively. So when a client fires a job, the input which comes from the client is basically a MapReduce job, and what you get associated is the name of a data set. So what name node does basically, it finds out the locations of data nodes where the data is distributed. Job track will split the job and send it to individual task tracker. So the MapReduce function is basically a program which gets transferred to individual data nodes. The task trackers would perform the map function. So map is basically processing. Reduce is basically collecting the results out of the map function. So map would perform a job on individual data nodes. Then the outcome of that gets accumulated at a reduced level, and the results which got generated at individual data node level at a reduced function finally get consolidated, and then the result is sent back to the job tracker, which in turn convey the result to the client. That's the way this basically works. So what is the benefit? This is basically entirely a distributed data processing. What is the benefit over here is that the MapReduce, as we discussed earlier, the processing in case of RDBMS is happening centrally. The entire data set and entire data volume is on one server. The entire processing happens over there. while this is totally a reverse. Data is distributed, and the MapReduce function, or basically a algorithm, is transferred to individual data nodes, so that that particular program runs at individual data nodes. And what those data nodes, those are all very commodity servers, the standard servers, whichever may be at your end. It need not be a very high class machine. I mean, we really don't need a RAID sort of a server. So here, whatever the hardware available, it can take benefits of that. That's the way Hadoop architecture takes the benefits of your internal commodity hardware. Now you can see the HDFS. So basically, the data which is stored into the data block gets stored into an Hadoop file system. MapReduce functions extract the data from the Hadoop file system, processes it, and sends it back to the masters. So let us try to understand in short how HDFS is structured. It's a block structured file we just discussed. The name nodes and data nodes are the piece of software basically, and so you'll have a separate machine. So name node is a separate node. It has to run on one separate machine, and while data node would work on to individual different machines. So name node is the master, and the only drawback of this architecture is if there is any problem with the name node, your entire processing goes on task. You can certainly have a backup of a name node. You can have a secondary name node, but you can't really activate it on the fly. You can't run it. You can do it on the runtime. So you have to really restart that name node service and restart your job. But you're not losing anything. But whatever the processing happening during that time certainly goes away. So as I said, the entire data is getting stored onto the commodity hardware. So there are high chances that there are failures with respect to the servers. We know how the servers can fail actually, and hence what Hadoop does is Hadoop does the replication of the data on 3 places. And so what happens at any moment of time, a particular server has some problem, a particular data node has a problem, that particular data can be extracted from another data node, and the entry are there in the registry of the name node where the replication exists. So though I would not say it's a very foolproof mechanism, but that certainly takes care of failure aspect of it. And it's very important when we are doing this sort of a huge data processing into the distributed environment. I will move on and we'll talk about the MapReduce work, and just wait for a sec over here. I just wanted to get some feedback over here. Is it going as per the speed? I just want to know when are there any views people want to convey, because I'm going with my speed.
Mr. Kulkarni, actually I have shared the questions with you, so if you want to take the questions, some of the questions.
I'm just trying to figure it out. How do I go to the questions? Just one second. Okay, I will, there are a few questions, but I really don't find those which are relevant to the topic which I have covered, so I will try to cover them later. Let me figure it out if there are any questions which I can, yes. Okay, so there is some question from Amol Malani. What he is saying is this big data mainly for unstructured data from social media related text data? Is it not a normal star schema of dimension, fact, measure? No, Amol. See, this is what we are talking with respect to the big data is mainly with respect to the unstructured data. Hadoop is a framework which certainly helps us to do the processing of unstructured data. It can very well do the analysis of a structured data, but it's not really meant for that. You already have a separate RDBMS world, the database world, who can help you into the structured data. And hence, yes, not only the social media, as I said, the data which gets generated, accumulated at the organization level, it's in the form of documents or Excel files or the PDF file. Certainly Hadoop can take care of those sort of data. So if you are talking about a star schema, facts, dimension, that's all related to the data warehouse. We'll go further, and then we'll try to understand how Hadoop fits into a data warehouse framework. As of now, I would say it has nothing to do with your star schema or anything. There is no structure. There are other columnar database are mean for that. There is no really a fixed structure for that, and they are mainly to process the unstructured data. I really don't understand this question. Maybe if a person can elaborate it. What is the base of nomenclature of a Hadoop? I don't know if are you talking about the Hadoop word itself. I feel that I earlier explained, but if there is a specific question which you want to ask, you can certainly write back to me. Okay, what is a good resource for understanding design patterns for using MapReduce? I would say, you go to Apache website, they have excellently explained the MapReduce in detail, stepwise with examples. So I would be sharing few links at the end of it, go through those links. But Apache Foundation specific link, it certainly helps you to understand the MapReduce function. How do you compare Hadoop to peer-to-peer computing? I really don't know whether I can compare peer-to-peer computing with Hadoop, because this is totally a distributed. Hadoop can be compared maximum with an MPP sort of an architecture. It can't be really compared to the peer-to-peer computing, because here we are talking about the distributed processing. Is there any data type constraints is there in the Hadoop? So Hadoop is not, as I said, it's a free data format. There are no data types as such. So when we go to the HBase or Hive, when we talk about very specific databases of Hadoop, we will talk about the data types. But here there are, it's all unstructured data which has to be really segregated in the form of columns in such a way that you make a sense out of it and bring it into some semi-structured format, which finally can be understood by the HBase or Hive. Algorithm like clustering and association, etc. on Hadoop data on real-time speed. Can we perform data mining algorithms like clustering, association, etc. Hadoop data on real time? Yes, we can certainly do that, and when we go to the big data analytics, we will talk about it. There's a question on ROI. I will take it later. Everybody understand ROI is a big thing. When we talk about the enterprise data warehouses, deriving an ROI is a big task. So we'll not spend time at this moment on that question. We'll move forward, and then we'll talk about MapReduce function. How basically it works. So this is a very simple example. Again, I'm sure you might have seen this multiple times, but I felt it's very easy to explain you how MapReduce works. This is a simple input file which contains a lot of words, and for simplicity we have taken just 3 rows from the file. And if I have to really find using MapReduce function what is the total word count at the end of it. So there you can see the words, deer, beer, river, car. If I want to find at the end of it, what is the total word count of each word? So this is a very simple example, but helps you to understand how MapReduce works. So what happens, once this file is sent as an input to the job tracker. What job tracker does? It splits this job into 3 task trackers. That is, each line is sent to separate task tracker, that is a separate data node, and along with that it forwards the MapReduce function. So we have so the MapReduce algorithm would have a capability to count each word into that function. So the mapping function would figure it out the occurrence of each word. So if you see the under mapping function, you will find in the first data node deer 1, beer 1, and river 1, it's occurring once at a time, and similar for the other data nodes. Now the next part is basically really shuffling, because you'll have to shuffle this data across data nodes so that the exact counts with respect to individual word is accumulated at one place. So that shuffling happens with respect to the individual word, and what reducing function finally does is it does the aggregation, and final results would be brought in the form of the word count as such. So once you give the input, it's just a simple example to convey how the map function works, how the shuffling happens, and finally the reduce function provides the result. It basically works under the key pair concept basically. So when the data is fed with the first data node, it's fed with the key that is the row ID and the contents of the row, and when the results come out, they comes again with the key pair as the key as in words, and then the associated pair is the count basically. So that's the simple way of explaining the MapReduce function. Briefly, just touch upon the Hadoop databases. Now, these are again open source databases. HBase is basically an derived from the Google's Bigtable. Google came out initially with Google File System, MapReduce, and then Bigtable is a database, columnar database which they developed, and that is the concept. HBase is totally based on Google Bigtable. It's a columnar database. It's a non-relational database, and it's a sparse database basically. When I say sparse, that one particular row may have 5 columns, one particular column may have 10 columns, or one particular row may not have any column as such. The reason for those sort of things is mainly because the data coming from the internet is many times very, very sparse. You can't really fit them directly into the row and column format. So there has to be a modeling facility or the flexibility to store that sort of a data. This is a schema on write against schema. It's a schema on read against schema on write. So what does it mean? Basically, all the RDBMS of the relational databases stores the data on schema on write. So whenever you are writing the database, then and there itself, the referential integrity, the constants, basically take care of validating the data. It throws the error there and there itself, and then we really correct the data and then again try to feed it into the databases. But here, what it happens is basically it's a schema on read. When the data is written into the HBase, or even that matter into HDFS as well, it's basically written as it comes. There is no validation done when the data is brought in. But when the programs like MapReduce functions are going to work on that particular data, they need to really do all those validations, check the quality of the data, and derive the data sets out of it. It runs on top of HDFS. If you ask me, does HBase stores the data in the form of tables? No, it basically stores as a file itself, and it stores the data into the HDFS itself. All the metadata tables are stored at the information available at the name node, but the data is again distributed across different data nodes. So the tables in HBase can serve as an input and output for MapReduce job function. So that is what all about HBase. So in short, it's an columnar databases is allow you to store the data in which is a semi-structured or a structured way, and it works on top of Hadoop basically. Now, what is Hive? Hive is basically an implementation of an SQL implementation on top of HDFS basically. We all are very much familiar or used to an RDBMS word. So if we have to relay derives, we have to fire certain queries on HDFS. Can we really do it? Certainly, there needs to be a level of analysis needs to be done on the data, and data needs to be brought at one level, and that entire thing you may perform through MapReduce. And then on top of that, you can create the Hive tables, and then you can fire the queries. There is a separate query language which Hive provide is HiveQL, and which helps you to extract the. It's basically query, but internally it fires an MapReduce function itself. But it becomes very easy for the programmers because we all are very accustomed to SQL, and we write the queries into SQL. But finally Hive takes care of converting into the MapReduce. This again came into the picture when Facebook was facing the challenges. As I was saying, there's a huge amount of MySQL implementations there at Facebook and as well, and their entire daily loads they were not able to finish into 24 hours, and they thought there has to be some mechanism. And at that time, Google, Yahoo started implementing. They felt, why can't we really go and try it out the Hadoop way? And finally, they felt that we can certainly build some sort of a layer on top of HDFS, by virtue of which we get an input which can be really passed on to the existing data warehouses. How currently the Facebook data warehouse works is basically the data coming from huge number of advertisers which are displayed onto Facebook. At the same time, the messages which are put in by the users, the comments, that entire data lies onto the web servers. From there, it is brought to the Scribe servers. From the Scribe servers, it is brought to the HDFS cluster. Now, that is all the factual data. Now, there are the dimensional data which is sitting into their MySQL environment. Taking that dimensional data and bringing this unstructured data in some form of structure way, they generate a lot of aggregation, which is finally transferred to an Oracle cluster, and they build the MicroStrategy reports on top of that. So that is the way currently Facebook is implementing Hive. So the data which is bought from the cluster, the Hadoop HDFS clusters, and the data coming from MySQL finally gets a treatment through Hive and then dumped onto the Oracle databases. So that is what in brief about the Hadoop databases. I will move on to Hadoop ecosystem. So we saw, there are 4 components as of now. We saw HDFS, we saw MapReduce, we saw HBase, and we saw Hive. Now when to use HBase, when to use Hive, it's all going to be an end user discretion, but a thumb rule, basically HBase normally is used to store the transactional data, while Hive would help you to build an analytical applications on top of HBase, at the same time HDFS as well. So Hive can directly access the data from the HDFS, or it can really access the HBase tables. So you can have multiple tables built on top of one HBase table also. That is quite possible. So it's all evolving technology, and it depends on individuals how the implementations can be done. Let us try to understand the Hadoop ecosystem. Apart from the databases we talk about, there are huge number of databases now into the picture, and pouring into the open world. They're all NoSQL databases. We talked about the graph databases, document databases. Then there's an administrative tool that is called as a Zookeeper, which keeps on doing the cluster management, basically the data node management, how the data should be moved, and it keeps on giving the input to. So whenever a job tracker has to work, it talks to name node talks to the Zookeeper, gets the input, and that's the way it understands where the data exists. So basically, Zookeeper is an administration tool. If you see workflow perspective, how do we really access the data? So there are a variety of ways. We saw MapReduce as one of the way. Another way is Pig. Pig is a high-level language. Pig, the MapReduce is comparatively a complex language. It's basically it's a Java implementation only. But any work which we have to do, if you really end up writing MapReduce, it's a time-consuming and it's an comparatively complex way of doing it. Though MapReduce has got its implementations in the form of C# and Python and whatnot, but again, writing scripts in MapReduce is fairly complex job. So Pig is a high-level language which can really reduce the complexity involved. And as I say, SQL, there are APIs available, in cases where you want to do some additional functionality. There are APIs for Java, for C++, C#. And there are tools available for building the analytics on top of a big data. Those are Mahout and Chuka. Now, this is only with respect to the open source world perspective, but there are tool vendors, and we'll go on see on the future slides, what the tool vendors are doing. I know the IBMs of the world and the Oracles and Teradata. What are they doing into the Hadoop? What we'll see soon. So briefly touch upon the differences. Hadoop is basically a data grid operating system, while it's an ACID database. We know what ACID is, all atomic and consistent and all. It stores the data in the file, while a relational database stores the data into the tables, can handle 10 sub petabytes of data, while it can handle hundreds of. There is a weak consistency of a data in Hadoop, certainly because there is no the way we saw earlier. There is a scan on the write versus scan on the read. So when the data is stored, there are no integrity checks done, and hence there is a weak consistency into the data. It scans all blocks in files while it look up rows using the indexes. Hadoop is used for querying and data processing, while relational database are mainly for queries. So, and it's certainly used Hadoop mainly for the batch processing as of now. There are, again, as I said, it's all evolving, and we never know, batch. We can start really getting the real-time Hadoop maybe soon. But as of now, it's a batch processing. Whenever you want to get the response is basically more than 1 second. But for interactive responses, you still need to rely on relational databases. Okay, so I'll just hold on for a sec, and I will go to the questions if any. Okay, there's a question like, why the reason big data and Hadoop is not discussed very frequently in the enterprises. So it's a totally very new area, Nidhi. It's for the question from Nidhi Sharma. This is a totally, as I said, it started in 2004 in Google, and already earlier got implemented mainly into the web companies, all those web companies who deals with a huge amount of data. And again, it is, it's still I would say at technical level, it has to really get down at the commercial level, though tool vendors are working. Enterprises would certainly able to understand it or make use of it when it is made available by the tool vendors. Though there is a starting, there is still a long way to go, and that's the reason I would say, being a totally new area, a niche area. And still, it's being handled by the engineers, still not really come up to the user levels. Okay, then there is some question. Let me try to understand. Okay, there is a question from Prashant Kumar. Prashant, I didn't get your question correctly. This is MapReduce is able to analyze the data as well in case there are errors and input. So yes, there are. It's again like in Java program, right? The way you write any Java code, you would do error handling, you will do exception handling. So that entire thing you can really do it into the MapReduce function. As data is sparse in HBase, how it will affect the storage? Will a lot of space will be left unused, or rather I would say it will not be left unused? This is a question from Anupam Baroa. See this, when the data is sparse, when I say the rows are stored with sparse columns, it would occupy only the space that is totally a reverse of RDBMS. We know in a table, if I have 50 columns, and if I really don't have a data for a few rows with respect to say 30 columns, still those 30 columns would occupy the space. While this is not the case over here, and that's the flexibility the NoSQL databases are providing us. What is the equivalent in Hadoop for inverting indexes in RDBMS. Usmani Faruqa. Usmani, we will talk about, so HBase is an whole lot of exploring area. To be frank, I haven't still explored the HBase that thoroughly, but I can certainly get back to you with this answer. The question is respect to what is there for inverting indexes. There is nothing in HDFS, but certainly when it comes to HBase, I will find it out and get back to you. Can Hive SQL work on unstructured data? How can query work on unstructured data? Certainly not. This is a question from Pradeep Moon. Hive will not work on unstructured data. What we really need to do, Pradeep, is we'll have to build MapReduce functions and algorithms which would run on that unstructured data and would create some sensible semi-structured or structured data out of it. Once that data is ready, then only Hive will come into picture actually. Correctness of the result provided through the Hadoop, how we can rely on the results. See, again, it's all programming, right? We are quite used to the tools or the databases which have matured over a period, right? And that's the reason we get these questions. But let us try to look into the earlier days where we used to work on the high-level languages or even the low-level languages. How we were really relying on to the outcome which was coming from those languages. It's all we will have to really build those sort of a checks. We'll have to really validate our data through the programs to ensure that the results are optimum. How do you implement retention and data archiving in Hadoop? Basically, as I said, data is getting replicated by default 3 times. You can increase this count when you set up your HDFS. If the data is getting really replicated thrice, you really don't need to archive it. And basically, you are not supposed to archive because that is the whole historical data on which the data scientists are going to do the analysis and are going to derive the sense out of that data. So we will talk soon what data scientists are all about, but that's a whole together a different breed of analysts who are going to work on the Hadoop data. So if we try to compare our RDBMS world versus Hadoop world, there is a lot of work for analysts, there's a lot of work for data scientists to do on the data to make a meaning out of that data. It's not going to be as simple as we firing some query or we firing some programs and making sense out of that. We'll go to a few slides later and we'll try to find out what data scientists normally does. So let me move back and go to the main topic. This is very important, Hadoop and data warehouses. What basically is there for data warehousing people when it comes to Hadoop? Okay. Before that, let us try to see what are the different changing scenarios with respect to the data warehouse. The enterprise data warehouse is evolving, changing over a period. We see data warehousing appliances coming into the picture, which can cope up with a high volume of structured data. Now we started getting the columnar databases, by virtue of which we can really access the data fast. So all our aggregations, take an example of SAP HANA, it's a columnar database where you can really, pull the data, generate the aggregations very quickly because it's not doing the full table scan. In-memory databases, again, they have changed the scenario because the processing becomes very, very fast. In-memory analytics, now we are talking about some real-time analytics, when we are putting some statistical algorithms to work on the databases, certainly it's going to take time because it has to run through multiple permutation and combination. And if you have some analytics which can really run in memory, that's going to give an optimum result. So that's another trend we have seen with respect to the enterprise data warehouse. And then certainly the social media and mobile analytics, which we talked about. And when it comes to the cloud, it's mainly with respect to IT infrastructure. So this is the way actually data warehouse is changing, and these are all enablers. These are certainly taking data warehousing industry to the next level. So three areas: IT infrastructure, storage and processing, and third is analytics. In all those areas, there is a progress. And next now is Hadoop. So how enterprise data warehouse and Hadoop can work together. Let us move on to the next slide and try to figure it out. The concepts of the data warehouse basically. So in a data warehousing scenario, these are the 5 steps which we normally follow, right? There's a data generation phase, data capture, data storing, and data analysis, and then finally the presentation layer. Now if you see how Hadoop is very strong into data capturing and data storing. While if you see the EDW, the data warehouse is basically very strong in analyzing the data and presenting the data in a nice way. But the Hadoop also has a very good capability of analysis, while data warehouse also has got very strong capabilities into storing the data. So if you see there is an overlap. They both can really take care of majority portion of work which is needed from the data warehousing scenario. But will that really affect anyway? Are we saying that Hadoop would replace data warehouse? I really don't think so, because mainly Hadoop analyzes the unstructured data. Hadoop is very specifically meant for analyzing the unstructured data, while data warehouse will still continue to analyze the structured data. So they are certainly going to complement. There is a huge efforts industry has put on maturing the database technology, and I really don't feel there is any reason to replace that with a new technology like Hadoop, but it's certainly going to complement. Hadoop serves as a data bag for data aggregation and pre-processing. Yes, when it comes to the enterprise data warehouses, data extraction is the biggest thing. Huge amount of data to be extracted from multiple sources. Can this work be offloaded to Hadoop? Yes, that is a possibility, and that is the way organizations are thinking of utilizing the Hadoop for data warehouses. Organization can even offload the data from EDW. So there are some utilities, the programs like Scoop, which can allow Hadoop to extract the data from the data warehouses. So as I was telling you earlier, a case of Facebook data warehouse. So what Facebook is doing is, again, using Scoop, they are extracting the data from the MySQL, crunching that data, processing it data with the unstructured data in a Hive, and then finally generating the structured data out to the Oracle. That's the example we discussed earlier. So that is another way. There is a new breed, I said, of analysts called as data scientists. So they really need to understand the patterns of the data. They need to analyze the data neatly to forecast it effectively, and hence, a amount of data from data warehouse and a huge amount of unstructured data can be used by them effectively using the analytical tools like SPSS or SAS. So push down aggregation, we can see that data warehouses, when you build a data warehouse and if you have to really do high amount of aggregation, that sort of a work can be pushed back to the Hadoop. It can be aggregated using Hive sort of an plugin or the language, and it can be extracted back into the data warehouses because Hive is all SQL. So there are three things which I can see in which Hadoop and EDW can complement each other. So unstructured data analysis and the structured data analysis can happen parallelly. Second is we can do push down aggregation. Aggregations can be pushed down to the Hadoop to get it done fast because it's a distributed processing. While even the ETL part of it, not just an extraction, maybe a transformation, if it is very complicated, very complex, and it's not fitting into your load window, you can certainly think of pushing it down to the Hadoop. But this is all when we have really huge chunk of data, when we are really talking about the petabyte of data, or really when we are talking about very, very complex data. Because you will not get those benefits if your data warehouses in few terabytes, utilizing Hadoop is not really going to give that sort of an impact, because the number of data nodes which will get involved to do that sort of a work and throw it back to the data warehouse, it may not be really uh, comparable when it comes to the performance. Relevance of Hadoop. I'll just briefly wait over here and see if there are any further questions. All the use cases, there is a question from Chandan. I will have to first digest this question, but I'm just reading for everybody's benefit. All the use cases for Hadoop are basically from web and text analytics. How can we leverage the benefits of Hadoop to perform analytics with both the streaming data as well as the data stored into the traditional data warehouses? Which might be the case. We want to move towards the real-time decision making. Yes, Chandan, it's an again emerging area. You rightly said, when the data coming from the stream, like the data coming from the sensors or the data coming from the RFID, it's coming into the streams. It's a huge volume of data coming in. Now, that is the job of data analysts who need to really make a sense out of data. Unless and until we have, so there's a heavy demand for this data analysts nowadays, because they need to first of all understand this data effectively. They need to make sense out of it. They should be able to correlate this data with the structured data. Unless and until we really getting strong into that area, it would still remain as a concept. I am totally with you. There is a time. Time is a factor. The tool vendors like SPSS and SAS are coming out with too many features which can ease the life of the data analyst, but ultimately it's the intelligence, the knowledge which data scientists are going to put based on their business knowledge, because they certainly has to understand the domain. They need to understand the data on which they are working. They really need to understand how they would really forecast, what they would really forecast out of it. Which are the sectors where the Hadoop could be of help? Will it be helpful in airport sector? Yes, I would say aviation is certainly, because as I was giving an earlier example, huge amount of unstructured data is getting generated. Currently, it is a retail who is trying to explore. People like Walmart who are exploring how best Hadoop can be worked. Another important area is telecom, because all CDR records, which comes into variety of format. The format really depends on the switches which are used at different geographies, and so it's a very fast data, and if we really want to do a churn and understand the customer churn, it's really it's going to be really helpful for the telecom industry. I was just talking to Greenplum folks, and they conveyed me one very good example of T-Mobile. They did a project in US where they found that over a period they are losing customers, and they wanted to really find the reasons, the patterns, and Greenplum. They use a tool called an Alpine Miner. Okay, so using the Alpine Miner, basically a mining tool, they could figure it out that normally if you in the US there is a group, you can form the group, and there are special discounts for the people who call each other in a group and so on and so forth. So if they found that, so what they analyze the CDRs, basically customer call data records. They analyze social media, and the people in a group. If one person leaves, and looking at his call detail records, if they find that he is a major user of that entire group, and if he leaves the group, then there is a 7 times high probability that that entire group may leave that service provider. Now, and they could provide, they could really, prove, they could prove it with the data, and which certainly based on that, Greenplum, the T-Mobile took the corrective action. They started tapping social media sites, and in real time they started figuring it out. What are the sentiments users has and what problems they are facing, and the success story, at least what T-Mobile conveys, is they could really improve not only the churn, but they could really improve their margins by somewhere around 70 million. So Greenplum is going to share that case study with us, and I can certainly discuss about that details later if anybody is interested. What are the career options available in Hadoop? I will talk on the next slides. So I'm on the last section of it. So what is the relevance of the Hadoop basically? So when we talk about the advanced analytics, what all advanced analytics is, it's basically all with respect to the statistical analysis, predictive analytics, data mining, natural language processing, so on and so forth. We all know about. We have that was the first session we have gone through with respect to the analytics in this TechGeek forum. So advanced analytics mainly deals with statistical analysis, and analyzing the constant changing data set would lead us to build a real-time analysis. So advanced analytics also deals with the real-time analytics. And what big data analytics is like any other analytics, but it sits on top of big data basically. But the benefits of the big data analytics, because it gives you a wide spectrum of data. You give the access to a wide spectrum of data, a huge amount of data, and understanding, analyzing the patterns out of it is going to certainly help organization which they haven't really explored before. Typical big data analytical applications, I can say, customer-based segmentation. Organization would be able to understand how the segmentation is, how the customer churn is, would be useful in the front fraud detection, risk quantification. I will not spend time over here because this is the standard stuff. It's just that a big data analytics working on big data and availability of a huge data, there is a high probability that data analyst can derive a better sense out of it and a better forecasting out of it. Benefits, certainly customer loyalty. You can improve the customer loyalty, you can improve the services, you can improve the performance with respect to the cost and quality. Let me move to the players, what they're doing into the market. All IBMs, earlier the world of open source now has, all the tool vendors have understand the importance, the seriousness of this particular topic, and they have really started bringing a lot of features into their existing tool, or at the same time they are coming with very specifically Hadoop-based databases. So Cloudera is providing the a platform called Cloud Enterprises, which provides you on NoSQL databases and all sort of utilities. And as I said, Cloudera is a company of duck cutting, so certainly it has got a good strong base of implementation now. EMC, as I was talking about the Greenplum, so the Greenplum has an Hadoop connectors, and you can really fire a MapReduce function, or rather basically they have the ability to access the Hadoop data, because Greenplum itself is an MPP, while Hadoop also works on the MPP principles. It can really take benefit of Hadoop framework through the connectors. So they have something called as an SQL MapReduce. That's the case of Teradata, Astrodata as well. They have the functions like SQL MapReduce, which can be fired directly from the Greenplum, and it would go on run onto Hadoop. So in short, there may be an unstructured data in Hadoop. I can fire an SQL query from Greenplum on unstructured data. We discussed this topic earlier. We can't really fire SQL query, but what benefits Greenplum is giving is you can really, the SQL function would convert the entire code into a MapReduce function and will really work onto it. Or the other way, you can really run a MapReduce function on the structured data. So that sort of flexibility tool vendors have started giving. Informatica has come with the tool called HParser. You can really call, you can access the Hadoop data to the Informatica mapping. So we can really pass the data to Hadoop for processing. At the same time, you can get the data back from. IBM has a platform called Big Insight, which has got analytics. It has got a tool like a Big Sheet, which can be used to access the data, analyze the data. We talked about SAP HANA. There is a tools, SAP, the SAS as well. They have SAS DI Studio. The same way I said, Informatica, they have capabilities to access from the data integration studio directly the Hadoop sources. So that's what with respect to the players. Big data in cloud, just quickly touch upon this area. If you see what Forrester said, Forrester certainly feels that Hadoop is going to be a feature for cloud basically. So if you search in it, you will find the definitions like big data is equal to cloud, but in reality it is not, because basically cloud is an IT resource deployment model, while Hadoop is basically a software framework to work on the large data set. They can certainly work together, but the future would decide. And the future may be really, if you talk about what is going to be the future of enterprise data warehouses, it may be like enterprise data warehouses deployed on top of Hadoop platform and deployed onto cloud. So that certainly will be a feature of enterprise data warehouses. Security layer for both Hadoop and cloud is still evolving. Cloud, we always hear that people are a bit skeptical, though there are a lot of enhancement happening and there are a lot of companies using clouds. But both at Hadoop level and at cloud level, the security is still evolving. Hadoop is basically technology is a technology originally built to utilize the physical servers, while cloud is all about virtualization. So certainly Hadoop will work on to virtual servers, but it's a matter of exploration. I really don't have those statistics in hand that what performance benefits I can get on physical servers versus virtual servers, but it's certainly a matter of exploration. Elasticity is a common thread, as being a distributed environment. Even in case of Hadoop, you can just, you find that we still need to get some better performance. You add one more data node, and you can improve the performance. It's as simple as what cloud does. Cloud can certainly add additional servers, and as your data grows, basically. So when it comes to it's useful in case when Hadoop needs a large number of data nodes on the case basis. So on particular case basis, where the elasticity is very important. Based on you really don't know for a given volume how many data nodes you will need, and maybe your current infrastructure doesn't provide that. You can certainly opt and cloud. We will see the New York Times case study soon and how they have handled the big data on cloud. So relevance to system integrators. Now this is important. There were questions coming. What are those? So what we as professionals will have to really learn, or what different job opportunities it would really open. There are new skills and roles, as I said, the developers, Java, Python, C++, because when it comes to really writing serious MapReduce, whatever the enhancement the tool vendors are bringing into their tool. But finally, if you really want to analyze your data based on the statistical model which you have developed, you will really need your own organizations, enterprises will need their own programmers who can really write the adequate MapReduce algorithm for you. So there is certainly a scope for the developers. There is a scope for the administrators, as I said, Hadoop clustering, implementing Hadoop cluster, securing, managing, optimizing the performance. That's all part of an Hadoop cluster administrator. The Zookeeper is another administrative tool which comes with Hadoop. So there is a scope for those sort of administrators. It's certainly not for the DBAs. There's a bit of an unlearning for the DBAs. This is mainly a job for system administrators, and there's hardly any role which DBAs has to play when it comes to the Hadoop sort of a world. And as I was talking right from beginning, there is a huge scope for the data scientists. It's altogether a different world. Now, as we were talking about just getting a data into HDFS and processing the data with the MapReduce, it's not going to be as simple as that. You need experts who understand what this data is all about. We need an expert who can deploy the predictivity models, the multivariate statistical models, the data mining algorithms on top of this unstructured data, and then they would be able to find out the actual knowledge lying there, and they can certainly provide the insight, basically. So based on so if it is basically with respect to the customer churn, the forecast may be at that level, looking at the social media data, looking at the customer data record. This is the forecast that following our 10 people which may leave our network soon. That sort of an forecasting, that sort of an insight is needed for the organization, and that can really happen only if you have very strong data scientists. So they have to have very strong academic background, they have to have very strong statistical knowledge, and they have to have very good understanding of the business. Because without understanding the business aspects properly, I really doubt whether they can really bring that sort of an insight for the organization. Sorry. Not least, last but not least, the most important area is going to be solution architecting, because here we are talking about multiple applications collaborating each other, multiple data sources collaborating each other. There's a lot of connectivity, and you really need a strong solution architect to deploy this entire framework for the enterprises. So, if we all are, if we are all worked into the data warehouse sort of an environment, yes, immediately there may not be anything where we can, we have any area to explore as such, but then we really need to, understand the pulse of the time, and we really need to understand the HDFS, the MapReduce, if not MapReduce, at least how Hive works, how HDFS works, and we really need to start gearing ourselves, understanding what tool vendors are providing, and we need to really start exploring those features, because that is going to be the future. The one or the sooner day, maybe next 4 or 5 years, we will see an integrated environment where people are not talking Hadoop separately, Hadoop becoming a part of an entire enterprise data warehouse umbrella, or maybe part of entire business intelligence, who knows. So Hadoop community, briefly as talked about, there are contributors, committers, these are all people doing it voluntarily. Committers are people who are technical experts, they can review the code generated by people and the patches, and they verify, they certify whether those can be released or not. There's a project management committee, it's a governance committee, and which takes a call when which releases to be done with respect to Hadoop. So Apache is a meritocracy, basically. Meritocracy is what? Basically it's an administration body which totally believes on intelligence, merit, and education. So they really validate that whatever the contributor is sending, what is that the background of a person, and whether it is really worth in bringing into a Hadoop world, and also can we really make this contributor as a committer over a period. It totally depends on individual skills. User contribution is growing, but Apache is calling all of us if we can contribute into this open community. Briefly touch upon this time machine case study. This is a New York Times case study which I was talking about. What they wanted to do is they wanted to scan all articles right from 1851 to 1922, and then later extended up to 1980. So all the more than 100 years articles they wanted to scan and build a website where called as a time machine, where users can go for any year and they can really go and open any newspaper which they really want to see at that time. You can see an example of a Titanic over here in 1912. Now there is an associated, so how they did it basically, all those physical newspaper they scan with the OCR files, the TIFF images basically, finally needs to be migrated to the PDF, but there has to be an associated metadata, because on a given page, on the given scan page, the cursor really need to understand where your image lies, where is basically the information, and where are the advertisers basically. So there has to be a metadata associated with that. Taking those TIFF images and metadata, generating those PDFs, then thumbnail, sequencing all those articles, storing that, it's a huge task. But the New York Times used the Amazon Cloud for this, and using Hadoop and MapReduce technology, finally they could finish this entire task in just 36 hours, just converting into the PDF, creating the thumbnails, sequencing, and storing. On top of that, they have come out with a website which, anytime you can go to the New York Times and you can access the time machine portal. Hadoop users are not touched upon this earlier. There are certainly initially all web companies, you see eBay, Facebook, Yahoo, and all. But slowly, as I said, the trend is changing. You can see usage getting more and more usage into the retail and telecom space. What next basically is these are the different versions. Those keep on getting improvised. As I said, 0.19. When actually Hadoop becomes an open source, the version at that time was 0.14. Now we are, as I said, there's an alpha version of 0.23 recently released, and it's getting day and day matured, and we would soon see Hadoop 1.0 coming out. Okay, the 0.23 provides HDFS federation, so data for different data. The data can be stored across a data nodes for a given data set. So those sort of variations or enhancements are coming with the new versions. So that's all about. I would just summarize in short what we talked about. This entire social media world has basically changed the overall scenario, which has really pushed the word towards Hadoop. Though still it's used by technology companies, as I said, slowly it has started getting into the commercial world, and the next 5 years are going to be very crucial. And if we all gear up to take it up, nothing like that. It's very scalable, extensible environment. Tool vendors are bringing Hadoop closer to the end users. And as I said, the ultimate goal or the ultimate picture which we see is cloud plus Hadoop plus enterprise data warehouse. As I said, we will have to unlearn certain things. We'll have to relearn few things, the skills needed which we discussed. And the most important message, again, while closing, I would say Hadoop and data warehouses are complementary technologies. And I'm quite sure all what we are doing will still continue. All the tools, technologies which we use with respect to data processing, with respect to the business intelligence would still continue, rather they would get more and more powerful. And if we all understand and start really working or exploring Hadoop, it's more better for us to be ready for the coming future. These are certain references. You can really look into it. It's a very good site from IBM Big University. It's a lot of videos, lot of documents, very well explained in simple way. And certainly, Cloud Era blogs, and Yahoo also has got very good tutorials. So have a look at these reference sites, and I have certainly referred it, and it's really helped me a lot. That's all from my side, and I have tried to take as much questions as, but still if you have very specific question, you can always reach me on the email ID which I have mentioned over here. Let me see whether I just briefly see if there are a few questions which I can really take. Okay, is there any restriction with server? On which server Hadoop runs? Totally not. There is no restriction at all. If you have a very old 486 servers, that still would work as a Hadoop server for you. No doubt, the tool vendors are coming with very specific appliances for Hadoop. So there's a Greenplum HD appliances, or maybe Netezza appliances who provides a very strong support and access to Hadoop. But I tell you, it's not really a mandatory thing. It would certainly help you to enhance your performance if you have the appliance sort of a thing. But again, it's a costly affair, and it's going to be an organization call. But to answer to your questions very clearly, yes, this is it can really work on any server. What are the operating system Hadoop supports? It's at this moment totally Linux, but it also started supporting Windows operating system as well. Master and slow nets in a desktop using VMware. Is there any hardware limitation? I really don't understand the question. Anupam over here, we say master and slave nodes in a desktop using VMware. I don't know. We are talking about different physical servers here. We are not talking about virtual servers. Yes, it would certainly, it can really work with the virtual servers, but the benefits which we will gain on the physical servers versus virtual are certainly going to be much, much better. What are the 3 replications than RAID? Okay, so we are not talking about any RAID technology, Victor, over here. We are talking about the simple servers, simple commodity hardware which we have, and HDFS on its own take care of replicating that data. If you have a RAID, the RAID would have its own replication mechanism. We are not talking about it, and you can still use a RAID, and RAID can keep on doing its job. But when it comes to the HDFS as a file system, it would take care of replicating itself onto the 3 different data nodes. That's what basically I wanted to convey. I feel I have covered most of the questions, and I would be really glad if anytime you can really get in touch with me on the mail ID we have given. It's all a new exploring area, and we all can learn from each other, and we can really form a very specifically Hadoop community for India, and we can take this knowledge forward. That's what I feel. Thanks a lot for everybody for showing such a great interest, and I'm overwhelmed. Thank you very much.
Thanks, Mr. Hemant, for your informative session on big data and the future of data warehouses. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. The next session in the Business Intelligence webinar series is happening tomorrow, that is 24th November at 3 p.m. Topic for the webinar is Open Source Data Warehouse BIA Primer. We will be having Parthasarthi Dorasamy, Principal Architect at Enterprise BIDI Solutions, as our guest speaker. So see you all on tomorrow. Have a nice day. Thank you.